It's that time again, time for some math. We are in Unit 2 on Lesson 7, so you need your Unit 2 math packet. And you're opened up to page 10. Yesterday we finished our Lesson 6 up here. Lesson 10 is toward the bottom of the page, so it's this page and then the next one. And today we're going to look at comparing decimal values. Yesterday you learned how to tell if decimals were equivalent to one another. And we're going to use that same process to help us when we're comparing. And when I say compare, I mean greater than, less than, equal to. So you can use place value to compare numbers using greater than, less than, or equal to compare each pair of numbers that they give you. And we're going to start with regular old whole numbers, a nice little blast from the past. And we always do use place value when we're comparing. So first off, when I see these two numbers, I notice they both go all the way to the thousands place. So I'm going to start all the way over in the thousands place, and that's how we compare, right? So remember back in the day, this has 1,000, so does that. So far they're the same. 200s, 200s. 5 tens, 5 tens. And now we get to the ones place, and I see this has 0 ones and this has 6 ones. Because all the rest of them, the place values match, having 6 ones versus 0 ones would make that greater. When you look at the next one, same. They both are 3,600. But now when I get to the tens place, this has 5 tens and this only has 2 tens. That would mean that would be greater. Now in looking at this last one, I don't really have to do too much here because I see that this one has a number in the thousands place and this one does not. So because this has a number in the thousands place, I automatically know that that's greater because the thousands place is greater than the hundreds place. That has 0 thousands and that has 1. So just kind of, thinking back, we're going to use that to help us in our decimal place values as well. So turn your page. I'm at the top of page 11 now. We're still in lesson 7. You must keep place value in mind when comparing decimal values. For example, 5 dimes would be worth more than 5 pennies, even though the number of coins is the same. Because 5 dimes would be worth 0.5 or 5 tenths, while 5 pennies are worth 0.05 or 5 hundredths. Now, with this, you might be thinking, well, when I think of 5 dimes, I think of 50 cents. So I would think of this as 50 out of 100. That's fine because that's actually an equivalent fraction to this, right? Couldn't you multiply 5 by 10 and 10 by 10 to get that? And same thing we learned yesterday. This point, 0.5, I can put a 0 in the hundredths place without changing the value of it. So when you see it like that, when you see 0.50 compared to 0.5, we can see, oh yeah, that is less. So that strategy that we used yesterday is going to come in handy of being able to put those zeros as kind of placeholders to the right of the decimal point. So we're going to start with some money examples because I feel like it just makes sense. Ba-dum-bum-ch. So here I have 0.05. This means I have 5 cents, right? 0.20, this means I have 20 cents. Well, what's more, 5 cents or 20 cents? Yes, 20 cents is greater. Here, $3.70, $3.08. Well, 70 cents is more than 8 cents if you have $3 for each, so that would be greater. And the last money example, I have $10.64 or $10.87. Well, the 87 cents would be greater because 87 is more than 64. All right, so now non-money examples. Those are always a little bit tougher. So we're gonna start here and notice that it goes A, B, C. So we're gonna go down each row here, down each column, and then we'll do the second column after that. So I'm just gonna focus on this side of the paper right now. So we wanna compare these using less than, greater than, or equal to. And remember, when we wanted to compare fractions, didn't we make sure that our denominators matched first because it was just easier to compare? It's a little trickier to try to compare 2 tenths with 200 thousandths because they both don't have the same place value in them, right? So we learned that I could write this as 2 tenths and this as 200 thousandths, and I can create a common denominator here. 10 times 100 is 1,000, so I can multiply 2 times 100 as well. So this would give me 200. 2 times 100 is 200 over 1,000. So 200 thousandths would look like that. So instead of doing all of this, if you have the understanding of these zeros that I'm adding here, I can add those two zeros because I'm multiplying the numerator and denominator both by 100. That's where they're coming from. But instead of writing that all out, I can just put them. So now we can see, because they're both thousandths, that these two actually match. This is 200 thousandths, and this is 200 thousandths, and 200 and 200 are equal to one another. Look at letter B. Here I see this is 40 thousandths. Here, this only goes to the hundredths. I want it to go to thousandths, so I'm gonna put a 0, and I can do that. It's kind of just like multiplying by 10. I didn't change the value of anything when I put that 0, because that's what happens when you're dealing with numbers that are to the right of that decimal point. I can't put zeros in front of that 4 without changing the value, but I could put as many zeros as I want afterwards without changing the value. It would all simplify back down to the same thing. So now we can see that I have 40 thousandths, and here I have 40 thousandths. These are also equal. Right, when you look at this next one, you might think, oh, well, 6 is less than 28. But this is 6 tenths, and this is 28 hundredths. In order to compare these, I need them both to be hundredths. To make this hundredths, all I need to do is put a 0 in the hundredths place. I did not change the value, I just changed what it looked like to make it easier to compare. So now we see this is 60 hundredths compared to 28 hundredths. 60 out of 100 is greater than 28 out of 100. For letter D, again, I might think, well, 17, that's more than 9, but this is 17 hundredths and this is only 9 tenths. So I need to make them both hundredths. That means I need to add a 0 here so that this is hundredths. So now we can see, more obviously, what's greater? Well, 90 out of 100 is greater than 17 out of 100. Next one, I see I've only used 2 places here, so this is 73 hundredths, this is 138 thousandths. I need them both to be thousandths, so I'm gonna put that 0 there. I didn't change the value of it, I just multiplied the top and bottom by 10 over 10 if you're thinking of it as a fraction. So now I can compare 730 with 138, right? Because they're both thousandths, and 730 thousandths would be greater than 138 thousandths. Next one here, I see 3 places here, I only see 1 here, I need 2 more places. So now we're comparing 456 thousandths to 800 thousandths, and 800 would be greater. Right, we're heading up to the next side. Now at this point, if you did want to press pause and try to do some on your own and then press play to check your work, that would be a good idea. We still will have a little practice session after this with your whiteboards, but you could start that practice now if you feel confident. Just make sure you double check to make sure your answers are right. Okay, I see 2 places to the right and 2 places to the right. I don't have to change anything. 3 hundredths is less than 23 hundredths. 3 would be less than 23 now that they're both out of 100. For letter H, the number in the ones place matches for each, and here I see 3 places to the right of the decimal. That means I need 3 places to the right of the decimal here. So this would be 6 and 800 thousandths, while this is 6 and 88 thousandths. 800 thousandths would be more than just 88. For letter I, this has 2 places to the right, this only has 1, so I need to add in that extra 0, multiply that fraction by 10 over 10, that's what you're doing. And I see that 50 out of 100 will be greater than 49 out of 100. For letter J, they both have a 7 in the ones place, so we're good. And now I see 2 digits to the right of the decimal point, that means I need to add a 0 here so there are 2 digits to the right. So now I'm comparing 7 hundredths with 10 hundredths, and 10 hundredths would be greater. Letter K, this has 3 digits to the right of the decimal point, so this needs 3 digits to the right of the decimal point. So this is 220 out of 1,000 compared to 222 out of 1,000. Even though they're close, this one would still be greater because 222 out of 1,000 is more than 220 out of 1,000. And last but not least, these both have a 2 in the ones place, and I see this has 3 digits to the right of the decimal point, so I want this to have 3 digits to the right. So now when you look, I see 40 thousandths, and here 40 thousandths. That means these are equal. All right, go ahead and grab your whiteboard materials or just some scrap paper so you can do the practice session next. Thanks for watching.